Welcome back, guys. In this lesson, actually, one of my students told me that he was a bit bothered by the fact that the grid size in our grid generator, by the way, we can add the grid generator right here so that I can show you. So this grid size could not go over 7. I'm actually going to drop a footage of the previous lesson so that you can better visualize what I'm talking about. So in this one, we are going to fix that. So while looking for a solution to that issue, I found this amazing post by Red Blob Games, and I highly encourage you to go have a look at it. I'm going to try and leave a link as a resource. But yeah, basically this post explains everything you need to know about hexagonal grids. And one thing that is going to be really important for us is something that we can find right here in the distances. We are going to use cube coordinates. So for that, we are going to use 3 variables, Q, R, and S. And I think that just above, you can see these 3 axes, maybe somewhere around here. Yeah, right here, Q, R, and S. Okay. So this is the coordinate system that we are going to use. To create our hexagonal grid, we need one condition. The sum of Q, R, and S should equal 0. So if you have a look at this tile, we are at 0, 0. So that makes sense. For this one, it's going to be 1 for Q in green, -1 for R, and 0 for S. So Q plus R equals 0. Same thing on any of these tiles. So let's jump back to Unity and see how we can implement this. Okay, here we go. I'm actually going to create a new scene because it's cleaner. Let's open the scenes folder, duplicate this sample scene, and we can call it sample scene hex test, or maybe new hex algorithm. There you go. Let's select our grid generator. We are going to add the grid generator script. And sorry for my voice, it's a bit clunky. Come on. It's getting cold out there, but yeah. So we can specify the grid even though we are not going to use it. I'm going to show you why. Let's lock the inspector to go grab our grid hex prefab. There you go. And now we can play with the grid size. As you can see again, if we increase that to over 6, so for 7, it's already looking weird. For a grid size of 6, it's okay, but yeah. If we want to create a grid size of 7 or 8 or 9, it's definitely not perfect. So let's open this script. We are going to duplicate this method, so Control-C, Control-V, or you can use Control-D, and comment this one. Boom, like so, and like so. Perfect. So in this method, what we can keep is the instantiation of our prefab. We can remove this line, we can remove this one and keep this one, but we are definitely going to change that. Anyway, as I've told you previously, we need to iterate over our 3 axes, Q, R, and S. Remember right here? Sorry for your eyes. So let's jump back to our script and change X for Q. Okay, let's change Y for R, and let's add another one for S. So Control-C, Control-V, and we will definitely need another curly bracket. Perfect. So this is going to be S. Here we go. Then we want to make sure that we meet our condition. So if Q plus R plus S is different than 0, we don't want to consider that iteration. We want to skip to the next one. Okay, so that we make sure that we have a correct hexagon shape. Then let's have a look at the blog right here and try and understand this a bit better. If we have a look at R, we can notice that the higher we go, the lower it gets. So -1, -2, -3, and -4. But if we go backwards, so along the -z axis, +1, +2, +3, +4, it does increment. So we can already imagine or deduce from that R is going to affect the back axis or the forward axis, depends on how you see it. So we can jump back to our script and already write something like vector3 R direction is going to be vector3.back. Got it? I hope this is clear. So let's try and find a similar strategy for the Q direction and the S direction. So how much we need to move along Q. So for Q at the top left, we can notice that it's 0 across this axis right here. And the higher we go, the higher it gets actually. So +1, +2, +3, +4. From that, we can deduce that we need to move towards vector right, rotated by 60 degrees. So 60 degrees, if we go higher in the post, somewhere around here, perfect, we can notice that the angle between one point and the other one is 60 degrees. And it's exactly the same thing for the middle points right here. So the middle of this segment and the middle of this segment make a 60-degree angle. So let's jump back to our script and write something like vector3 u direction will be equals to vector3 dot right dot rotated. We can't do that, but what we can do to rotate a vector is multiply a rotation to a vector and not the other way around. It will not give a vector. So make sure to start with the quaternion dot Euler rotated by 60 degrees along or around the y-axis, so 0, 60, 0, times vector3 dot right. Got it? Let me actually show you that you can't multiply a vector to a quaternion. Error, okay? We cannot apply this between a vector3 and a quaternion because the quaternion here is a rotation and it is a matrix. So you can't multiply matrices in the order that you want, okay? So let's hit Control Z a bunch of times. There you go. So we've got our Q direction. What we can do is now jump down to our thingy right here and apply the same logic for the S axis. So we can notice that S increases when we go left, okay, but decreases when we go right. Got it? But it's not as simple as it gets because we've got -1 right here on the right, but it's actually a diagonal. Same thing that we've done for Q, okay? So it increases or decreases along this diagonal right here. So it's not 60 degrees in this case, but 120. So let's jump back here. Vector3, let's call it S direction equals quaternion dot Euler 0, 120, 0 times vector3 dot right. And just like that, we've got our 3 axes. But this is not it. Now that we've got the axis, we need to know by how much we need to move along these axes to determine our spawn position. So let's write or use some 2 variables that are going to come in handy. So float, height. This is going to be the height of our hexagon. Let's write hex size multiplied by 2. So we can create this variable somewhere around here. Float hex size. There you go. And regarding the width, what you can do, by the way, is jump back to the blog post and have a look at this. If we are using a pointy top orientation, the width is going to be twice the size, as I've just told you, but the height, sorry, is twice the size, but the width is going to be the size multiplied by the square root of 3. This is how hexagons work. So let's jump back to our script. Float width is going to be the hex size multiplied by the mathf dot square root actually of 3. There you go. So let's now try and calculate our spawn position. Let's not use the grid. Okay. Let's start with a simple one. We know that the R direction, according to this diagram right here, so let's jump back down again. I just want you to see it every time so that you can better understand. But if not, make sure to just sail through the lesson. If we have a look at the spacing between the center one and this one, we can notice that it is 1.5 times the height. Okay, 1.5 times the height actually, because between this row and this row, it's 1.5 times these the size. Sorry. So let's have a look at this. Actually, you can have a look at the vertical spacing and the horizontal spacing. It's 3/2 or 1.5 times the size, and we've got 2. So let's jump back to our script here, and we can already write R direction times height times 1.5, okay? Plus Q direction times something, plus S direction times something. So what is this something here? Let's jump back to our blog post right here. Let's jump down. There you go. We can notice that the distance between this point and this one is actually the width of our hexagon. So it's really straightforward. Let's jump back to our code. Let's replace our dots by the width. And same thing here. Boom. And this is our spawn position. Let's give it a shot now. So let's jump back to Unity. No need to hit play. Let's set a grid size of 2, okay? And increase or diminish our grid size. Okay, so that's 6. Okay, what the heck? Why isn't it working correctly? Let me just double check that. So seems like we've got all of the hexagons at the same position right now. Oh, come on, I did not multiply by R. So times R times Q, so Q, and finally times S. Yeah, that's way better. Come on. How did I forget about that? Sorry. So now it should work correctly. Let's try 1. Okay. So the hex size is actually 1. Let's write 2. Nice. 1. Okay. 3, 4. Let's go to, or switch to the top view. Okay. That's way better. Nice. 5, maybe. 7. Now it's working for 7, 8, 9, 10, and so on. So now you can go over 7 and you will still have a correct, well, so, okay, so it's a bit too much right here, but yeah, let's keep it small. So 3. Cool. I really hope that you've enjoyed this lesson, and please make sure to go have a look at this blog post if you want more info on the hex grid topic. Yep. And yeah, see you in the next one. Cheers.